Hello everyone and welcome to my YouTube channel Study with Dani. My name is Daniel Lottery and I'm excited to have you here. If you are new here, kindly subscribe to the channel and click on the post notification bell icon so that you don't miss any new video. From the title, I guess you already know what this video is about, so let's get right into it. In your machine learning journey, then you do feature selection and cross validation, which is very important in the machine learning procedure. You can choose not to do feature selection like I have seen in various publications, but this step is really critical to achieving a higher accuracy. Then the next part of the tutorial will take you through how to train and test your machine learning models. Training is how you actually teach your model to make predictions, and testing is you rather test it on a different set of data that the model hasn't seen or the model hasn't been trained yet. And then finally, we evaluate our model performance where we use statistical metrics and graphics to show whether our model is performing well or performing badly. And these are the results that you need to show in your project work or your publication. So like I said, at the end of this course, it is my expectation that you'll be able to actually come up with your own project using the codes that I'll show you here. And you can even publish your work using the fourth point, which is the evaluation of your model performance using statistical metrics and graphics for visualization. All right, so the presentation today is going to be as follows. First, I'll take you through the introduction. Then we'll do the first part of the tutorials, which has to do with data pre-processing, feature selection, and cross-validation. Then I'll take you through training and testing of your model and evaluating your machine learning model. Then we just have a brief recap. All right, so if anyone has any questions, they can put it in the chat, and I think Amin will monitor and let me know if there are any questions. All right, so first, the introduction. Okay, so basically what people want to know is what is machine learning? There are various definitions of machine learning, but then I will simply put machine learning as having a model or building a model and then teaching it to make predictions without any programming. So you train your model using codes, obviously, but then after, the model can make its own predictions without you training it again or you programming it or you telling it what to do. So why do we learn or why do we focus on machine learning models? So machine learning models has become important because there's a saying that the human beings do not utilize their brains to its full capacity. I think we usually use about 20 to 25% of our brain. This is because in your life as a human being, you are focusing on what to eat, what to wear, who to talk to, how to pay your tuition fees, which friend you are angry with. So the brain actually has a lot of things going on. As such, it is necessary or important to have a machine that focuses on a particular task. All right, so we use machine learning models or we train machine learning models so that they will have the ability to identify patterns in highly dimensional data. When I say highly dimensional data, I'm talking about, for example, you have a 10-column data. This is a highly dimensional data, okay? How do we know that if column 1 is low and column 2 is stable and column 3 is high and all of those stuff? How do we realize it using our eyes or our normal brains? It's difficult to do that. Hence, it is important to have a computer or a model that can do that for us. So machine learning is actually a broad field, but we have some major techniques. But we are going to focus on two, which is the regression, which is predicting continuous values as in, let's say, a range of 1 and 1,000. All right. And then we have classification, which is either we are classifying A or B, true or false, or images. All right. So whether this image is a cat or a dog. So these are like the main two machine learning techniques that are in use. We also have clustering, and what clustering does is, in the case of reservoir characterization, you have your gamma ray log, right? And we know that sandstones have a particular gamma ray, shales have a particular gamma ray value, and siltstones, carbonate, coal, they all have their own unique gamma ray values, although some of them overlap. So we use clustering to find the structure of a data, that is, which part of the data represent sandstones or shales and all of those stuff. All right, so I'm sure some of you have heard about deep learning, artificial intelligence, and machine learning. All right, so what are the main differences between these three important tools? When we talk about artificial intelligence, we try, this is, let's say, a model that tries to make computers intelligent by trying to copy the cognitive function of the human brains. All right, so artificial intelligence actually covers a wide scope, which includes computer vision, which involves maybe using images to train your model, natural language processing, which involves text, or probably, let's say, voice recognition. Machine learning is actually a subset of artificial intelligence, and it mainly focuses on the statistical part. It tries to teach your computer or your model to solve problems by looking at a wide variety or highly dimensional data. It learns from the data to know how the data evolves over time or depth or range, and uses the experience of its learning process to solve the same problems in new data. Right, so the revolution in machine learning actually refers to the deep learning, where computers actually learn and make intelligent decisions on their own. So in this case, I'll point out deep reinforcement learning, where the model is trained on a set of policies and in an environment. So when the environment changes, the model will keep on making mistakes until it fully acclimatizes itself to the environment. And this is mostly used in robots or machines. All right, so the machine learning journey involves several steps. One of the main important steps is the exploratory data analysis. In this step, we input our data by using import libraries. Then we clean the data by using simple data pre-processing steps. We try to visualize our data and then do some statistical analysis to help us understand what you are dealing with, as in how the data relates to what we want to predict. Then we have to also learn about the existence of multi-collinearity, which is actually not really good for your machine learning predictions, because when we have some data telling us the same thing, it is better to have one of them than to have both or all of the data which tells us the same thing. This makes it easier for your model to learn adequately. Okay, then we have to do something called dimensionality reduction or feature selection, which tries to reduce the dimension of your data. So if you have a 10-column data, this process will reduce it to probably 8, 5, or 6. This is done because not all the input data will be relevant or important to what you are trying to predict. Okay, then after that, we are going into the main topic, which is the model training and testing. But before that, we will have to perform cross-validation. What cross-validation does is it divides your data into different subsets. So let's say, for example, you have a data of 1,000 points. you divide it into 70, 30%. So the model will use 70%, representing 700 data points, which is selected at random to train. And once the model is done training, it will try and test its performance to see whether it trained itself properly or not on the other 30%. All right, so the next will be model performance and model optimization. But for this course, we will just end at model performance. But after you optimize your model, you then have to deploy the model and then monitor it to see if the model is performing well or you need to do something different to increase its accuracy. In the academia, mostly we don't focus on the deployment and monitoring stage, but it's also an important point in the machine learning journey. So once we test our model performance and see that we're actually getting good predictions, then we end our project. So this is actually the whole journey of machine learning in, let's say, your research or your project work. Okay, so I'll quickly just go to my Jupyter notebook. I don't know if you guys have access to it, but you can just follow me if you have Python or Anaconda installed on your PC. So like I said, the first important one is to import your data. So first of all, we start to import pandas. I know this is not the basics. I'm not going to focus so much on it, but if you are interested in learning about these basics, I have a video uploaded on YouTube. I'll share the channel with you guys at the end of the tutorials. Okay, so pandas is actually a library that deals with data sets in tabular format. Okay, so we have to import pandas as PD. This helps us to not type a lot because instead of typing every time pandas, you can just shorten it as PD. You can use any abbreviation that you want, but the conventional or traditional way is to import pandas as PD. Then we import NumPy as NP. So NumPy is also a library that deals with numbers, basically. And then we import matplotlib.pyplot as PLT. So matplotlib is actually a visualization library that we use to visualize our data to help us draw patterns and make inferences from how the input data relates to the target. And then there's another important library for visualization, which is Seaborn, and we import it as SNS. It also performs, let's say, more advanced visualization than matplotlib. And then again, we have to import matplotlib. Sorry, from matplotlib, we have to, because matplotlib is a library on its own, and it has other sub libraries. So what we are trying to say is within matplotlib, import pyplot. Okay, so there will be instances where we will have to use pyplot. Pyplot has some settings which is actually different from matplotlib.pyplot. Right, so the next one, this is just a code to hide warnings. You can leave it, you don't really need it. And then this is also to make sure that all our visualizations happen inline. You can make it happen to the side, like when you want to show a graph or a chart, you can let it go to the side, but I think I prefer it to be beneath the code. Okay, so I think at the end of this course, I'll share the notebook with anyone who wants it. So this code, you don't need to change it. It tries to create high resolution images when we make our visualizations. Okay, so we are first going to import our wireline logs. All right. In this case, wireline logs is mostly imported as, or it's exported from Petrol as LAS files, but I've already converted it from LAS to CSV. There's a library that you can also use when the model is in the last file format. That is also on YouTube. I'll share that with you. So how do I get my file? So I want to import this file. Okay, so what you have to do is click on Shift, right click on your mouse, and then copy as path. All right, so in order for me to import my data, I need to name my data as a variable. So I'm going to name it as df. So that's a variable. So what am I assigning to df? I'm just saying in pandas, because I'm dealing with a table, read CSV, because the file is a CSV file format. All right. And then I put R because I want it to read. And then I'll input what I copied previously. Okay, so that is clicking on Shift and right clicking on your mouse, and you copy as path. So it just copies the file path here. All right. If you remember your file path and you want to type it in, you can also type it in. So now to run this first code, you can either click on this one, or you can click on Shift Enter. When you click on Shift Enter, it automatically moves to the next line of code. Okay, so it will take a few seconds to import all the libraries, since this is the first time using it after I restarted the PC. So once it is done, I'm going to import this table. So once it is done, you see a number appear here. That shows you that the code is done. And you can also see that this is hollow. It's not a solid circle, it's hollow. That shows that your code has finished running. So now I'm going to import my data, but I want to visualize the data by using df.head to look at the first 5 rows of my data. Okay. So this is the first 5 rows of my data, and I have depth, caliper, density correction. I have shear and compressional sonic, gamma ray, neutron, PEF, photoelectric factor. I have my resistivity logs, density, ROP. These are also resistivity logs. I have porosity, permeability. This is horizontal permeability. Sand flag tries to tell us which interval is sandstone, which interval isn't. And we have the water saturation, and we have our visuals. So again, what I'm going to do next is I want to move depth, this, to be the index, so that I don't see 0, 1, 2, 3. I want to see depth on this side. So in order to do that, this helps you to, let's say, not get confused with these numbers. You can leave it, but I recommend that you do it. So df, which is the table. So I'm just telling the table that set index and use the depth as index. Okay. In place equals true. In place equals true means when I do the change, I want it to be saved. If you don't put this in, you'd see the change, but it wouldn't be saved. So your next time that you input df.head, it will still show you this. So you always have to input in place equals true. Right, so as you can see, the depth is now my index. And this is showing the first 5 values and the last 5 values. All right, so the next important thing is to also check for your data type. So since our data is saved as df, I want to say df.dtypes, which is data types. Okay, so it just tell us what are our data types, and it's telling us every one of the data is float, but the sand flag is integer. Integer has to deal with 0 and 1s, and float has to do with decimals. There are different types of data types. We have the strings. So I'll just recommend that when you're doing your project work or your research, you can read about data types in Python. So now let's go to the first step of our data pre-processing. What we want to do is we want to check if we have missing data in our data sets. If we have missing data, the model will not work accurately. So it's always better to remove missing data. So I'm going to name that variable as missing df. And I'm just saying within the data frame, because my data is saved as df, within the data frame, okay, which of them is 0? Is null means is 0, right? And then I'm going to add a computational function, which will go through all my data sets. Okay, so for each column in missing df dot columns dot values dot to list. So what this is saying that for each column in missing df, which is from this, right, create a list. Then you print column. I need to correct this. You print column, and then you print missing df box bracket column dot value underscore count. What this is doing is I want the code to count the number of values, whether there are missing data or not. Okay, so then finally I'll ask you to print. Let's run the code. Right. So the first print is the column. Okay. And the second print is trying to say that if we have missing data, which is this df dot is null, if we have missing data, show it as true. If we don't have missing data, show it as false. All right, so when you go through the data, it shows that this has 1 missing data, the neutron has 2 missing data, density has 2 missing data, and it goes through like that. So now that we know that there are missing data in our data set, what do we do? How do we remove the missing data? Okay, so we have to create another variable, which is df underscore data. You can name it any way that you want, but I prefer df underscore data. So we are saying that within the data frame, drop NA. NA means not a number. So if you can see here, you see NaN, not a number. Okay, so these are not numbers and we can't use it in our machine learning training. So we have to remove it. So we just use drop.na and then I'll show you what happens. So you can realize that if I run the code, this row will be deleted. So you can check the first row, 3429.2 meters, and the next row, 3429.4. So just try and remember this as I run the code. So you see the columns or the rows that had missing data has been removed. There are various ways of dealing with missing data, but I think for the beginner level, it is better to just remove it. If you remove it, and assuming that you have 1,000 missing data, then you don't need to remove it. There are different ways of handling missing data. But because I don't have lots of missing data, like 2 rows, 1 row, and all of that, I prefer to just remove it since it doesn't really affect my data. And then in machine learning, we just know that our reservoir interval is a stand interval, and most of the missing data were within the shale area or non-reservoir interval. So removing it will not really affect my data set. Right, so the next thing that we'll do as a form of data pre-processing, cleaning, and trying to understand our data is to perform statistical analysis. Right, so statistical analysis gives us, let's say, it gives us how the model shows the range, the standard deviation, the mean, and the quartile ranges. Okay, so since our data frame is now df_data, that's what you need to type first. And because we want the descriptive statistics, it's just simple. It goes with a name. So you add dot describe, okay, into brackets, and just add include all, because we have different types of descriptive statistics depending on your data set. So I want to include all so that it will show me my count, that's the data, number of data that we have in the data set, the mean, standard deviation, the minimum to the maximum interquartile ranges. Okay, so if let's say you are publishing your work or you are presenting your work and you are using confidential data, so you don't want to share the data, you can actually share the descriptive statistics. All right, so the next thing to also do is to check for correlation. You remember what I said about multi-collinearity? It's not really, really good for your machine learning model, so we have to check for correlations to see which of the inputs has a high relationship to the target or your output. So to do that, I'll use the variable COR. That's in reference to correlation. And I want to work with df_data. So .corr, which is also correlation. We have different types of correlations. We have the Pearson, Kendall, and Spearman. I am going to use Spearman. You can use any that you want. You can use either Pearson or Kendall. I think the default is Pearson. So if you want to use Pearson, you don't need to add this. You just delete this. Okay, but I want to use Spearman because Spearman works well with skewed data. And from my descriptive statistics, I can see that most of my data as skewed data, especially when you look at gamma ray. The standard deviation is 23, but the maximum is 127. So you realize that it is actually right skewed. Okay, so I'll prefer to use Spearman. And then I want to show my result as a figure. So to show it as a figure, I have to plot it PLT. Remember matplotlib.py, and plot was saved as PLT. So plt.subplot. And then we want to define our figure size. You can leave it, but sometimes it will show you as a really small figure. So I prefer to set it. So if you are using this code, you can change this anyhow that you want to any dimension that you want. So I want the map, and I'm going to use SNS, which is the Seaborn library. So I'll input my variable COR, okay, that I want it to show me COR in form of a heat map. So the subsequent codes that I'm entering, you don't really need to focus on that. You can leave it. But I want to show the figure so that you understand it clearly. So CMAP is the color map. There are different types of color maps to use. I am going to use red, yellow, blue. Okay. And then the line width is the line between the different columns or the different data sets. So I'm going to use 0.5. X equals X. Okay. So we want to set the size. So setting size is basically the when you have the map, you have the columns written around it. So what I am trying to do is I want to make sure that the right side has no writings so as not to confuse you. The top also has no writings, and the right label will also be off, and the top label will also be off, and the rotations will be 90 degrees. So once I do that, I want to save my figure, right? So to save the figure, which you can use for all the images that you generate from your work, you can also just use your snipping tool to screen grab the image, but it's better to save the figure. So we are going to save this as Spearman row correlation, and you have to specify the file type. You're going to save it as JPG. So you have to always put it in inverted commas. So the format, JPEG, and then the DPI, I'm going to set it to 100. You can set it as high as you want. Sorry. So once I run it, I had an error. It's trying to tell me that I haven't done something, which is I didn't close the brackets here. So it's also telling me that CMAP, okay. So sometimes the code will tell you where you have the errors, and then you have to go and correct it. So let's give it a few seconds and to run it and show us, right? So this is the map, the heat map. Okay, so in heat maps, I've left some instructions here that can help you to understand it. Okay, so you can just read about correlations and try and understand. If your input variable is high, what does it mean? Is highly correlated to your target? What does it mean? And if it's low, what does it mean? Okay, so in this tutorial, I'm going to focus on the permeability log. So we are going to predict permeability. So to do that, I need to check which of my input data is highly correlated to permeability so that I focus more on those data sets. So remember, permeability is KLOGH, okay? So I just want to say relevant features should be equals to the correlation target, because I want to say permeability is my target, right? So correlation target, box bracket. I want the input data that is correlated to the target, but above 0.5. So then after that, show my relevant features. So what this is showing me is all the data that is above 0.5 when compared to permeability. Okay, so that shows that gamma ray is highly correlated to permeability, which makes sense because we know that sandstones, which has low gamma ray, actually has high permeability. Shales, which has high gamma ray, has low permeability. So it actually makes sense. And then there's a relationship between permeability and porosity. Okay, and density is a porosity log. All right, so this is actually making sense, meaning that our data is actually good. There's nothing wrong with our data. So that is actually the first step of performing data pre-processing. We can also use this Spearman correlation as the beginner's feature selection. So for example, based on this result, it's trying to tell us that if you want to predict permeability, you need to use gamma ray, the photoelectric factor, your resistivity logs, density, porosity, and visuals. You don't really need sandstone because it's a classification data. That's for a different project. But also when you look at the visuals is actually measured from your gamma ray, so it makes sense here. But then if visuals is made from gamma ray, why should you add visuals to it when visuals shows almost 1 in terms of correlation to gamma ray? So in using Spearman rule, you can perform your own feature selection by saying, I want to predict permeability, I want to use these logs, but visuals is highly correlated to gamma ray, so I will not add visuals. The resistivity logs are also somehow related to each other, as you can see here. So you have to remove one. For example, RT here is almost the same as RPC-LM, which is the slow resistivity log. So you have to remove one and keep one. So this is a simple form of feature selection. I don't really like this one. There's a more advanced type of feature selection, which is called explainable AI, but that's not important at this level. So I think the most important thing for me now is I'll try to teach you other forms of feature selection, and then we can take a 5-minute break if you guys want. So after we perform our statistical analysis, we now want to divide our data into the the input and the output. So we assign our input to X, right, from the DF data, which is the data without the missing values. And then we say remove, because we want to do feature selection. So we say remove our target, which is our permeability log. And then we say with Y is our target. So it's just df underscore data, box bracket, PLOGH. So these data is like two different forms. One will not have the permeability log, and one will have just the permeability log, and that is our target. Target is what we are trying to predict. Okay, so because we want to now split the data into train and test, we need to import the train test split library from sklearn. Okay, so that is the code to import it. And then in order to use it, we have to say X train because we need to train our data, and X test, Y train because we've divided the data into input and target. So we are just trying to say with the input, divide it into train and test. With the output, divide it into train and test as well. So this will be equal to train test split, which is the library that we've imported above. You can just import it as, let's say you can do something like as TTS, and then instead of typing this, you just have to type TTS. So let me just use TTS to show you how it works. So we say with the X and Y, which we've defined here, okay, we want our test size to be 15%. You can set your test size to any value that you want. You can make it 30%, you can make it 20%, any amount that you want. And then we want to set the random state to 1. So random state is because this code is run like the data sets are selected in random. Every time that you run it, it will give you different values. So we want it to use the random state of 1. So every time that we run it, we will get the same values. So the next point is to print. So what we want is we want to tell the code to print number of test samples, which is x underscore test dot ship. And then the same thing, but let me just copy and paste, print number of train samples, and we change this to x underscore train. So this is what the model is telling us. The model is telling us that from the entire data set, it has divided the test and the train data into these number of rows. So if you would remember, we have 2,125 rows. And if you add this, it gives you the same value. Okay, so now I want to just set something for later, which you would understand later, but for now, probably don't focus on it. I just want to say, for my sun flag, sorry. Just setting my sun flag aside. I'll use it later. So now that we've divided our data into train and test, let's run some advanced feature selection. So we are going to use random forest, which is an ensemble model, and the feature selection from random forest is an intrinsic method. I prefer random forest for a beginner. So you have to import random forest from sklearn ensemble, import random forest regressor. Okay, so now that we will import a random forest, we want to set it as a model. So the model is equal to random forest regressor. Okay, then you open a bracket. But that one also, it runs randomly. So we want to use this random state of 1 all the time. So what we want to do is we want to train the model. And in training the model, there's a simple code that we use. So we've saved the model, random forest regressor as model. So now we want to train the model. How do we train the model? We train the model using model.fit. Fitting means we are training the model. Then you input your X and your Y data. So once this code is running, it's trying to fit the data or the model to the data to try and understand it. Okay, so this code is a little bit complex, but I'll just make it brief. So what this code is trying to do is we want the important features. So we set importances as the model, which is random forest dot feature underscore importance. So you can do something simple. You can maybe run this. Let me see if this will work. Print. I haven't tried this way before, but let me see if it will work. Okay, so it didn't work. Okay, so let me just take you guys through. So what I am trying to do is I want the important features that random forest realized to show. Okay, so this code is just used to show it, and then I will save it. So don't worry, I'll give you this code at the end of the course so that you'll be able to understand it. So what this is trying to say is that visuals and gamma ray has high importance in predicting permeability. And it makes sense because, like I said earlier, low gamma ray signifies high permeability. High gamma ray shows or gives us low permeability because they refer to shale stones. Okay, so it really makes sense. Okay, now what we are going to do is we are going to remove the less important features. And in order for us to remove the columns, we use the code .drop. So remember we divided the data into train and test. Okay, so because we've divided into train and test and it has all the input variables, we want to remove the low ones, but these are not really important in predicting permeability. Remember I said sun flag wouldn't be important. So we use this same code x_train equals x_train dot drop, and you type in the columns or the column names, and you do the same for your test data. So now you can see here we have 17 dimensions or 17 columns. Now, after removing 4, let's see what we have. We have 13 now, but the rows remains the same. It's just the columns that we have reduced. Okay, so this is an advanced form of feature selection. So we have 13 columns, but when we use the spearman, it was going to give us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. So you can see that these feature selection models works differently. Okay. Thank you very much for staying with me throughout this tutorial. As this is only the part 1, you are advised to watch part 2 to understand the full journey of machine learning for beginners, an application to reservoir characterization. If you like this video, give it a thumbs up, subscribe to the channel, and share with your friends. If you have any question or topic that you'd like help with in learning, leave it down in the comment section and I'll try my best to attend to it. Click on the post notification bell icon so that you'll be alerted whenever a new video is uploaded. Here at Study with Dani, we teach in order to learn and we learn in order to teach. Stay safe. Bye-bye.